So up at the top, greatest or intro to factoring. And then where it says factoring polynomials using the GCF, so the greatest common factor, which we will probably almost never write out, we'll abbreviate it as GCF, is a monomial that divides evenly into each term of a polynomial. So I'm going to give you guys a chance to write down like the title and then that definition for GCF before we get started all together. So the greatest common factor from the Ed puzzle and then from the GIM kit that we just did, that was just the greatest common factor of just like kind of regular numbers, numerical values. Now that we're transitioning into like we're in the polynomial chapter, we're going to now have to include kind of different things like variables and exponents. But I promise that they just kind of build on the concept that we've talked about or that the Ed puzzle talked about yesterday. So just a kind of refresher, if I were to find let's say if I wanted to find the greatest common factor between like 16 and 24. So one way is, and some of these things will start to come more and more naturally in your head, some of them will, and that's okay. One way to find the greatest common factor between two numbers is to go ahead and list the factors. So if I were to list the factors of 16, well, I know 16 is like 1 times 16. I could also use like 2 times 8. It could also be like 4 times 4. And then if I wanted to put those in order, just so I can kind of see what the actual greatest is, let me scroll this up a little bit so you can see it better. You can ignore the stuff above it. That's from our previous notes. So if I were to list those just in numerical order so we can actually compare the greatest one together, it'd be 1, 2, 4. I don't have to repeat 4. And then 8 and 16. So those are all the factors of 16. And then if I were to make a list of factors for 24, I know that 24 could be 1 and 24. It could be 2 and 12. It could be 3 and 8. And it could be 4 and 6. And then if I want to list those in order, it would be 1, 2, 3, 4, 6, 8, and then 12 and 24. And to find the greatest common factor, you're trying to find the largest one that they have in common. So if these are the list of each factor, this is for 16, this is for 24, the largest one that they have in common would be 8. So the greatest common factor of 16 and 24 would be 8. It's basically the biggest number that you can divide into both of them and get a whole number out. So you can always make a list if you need to. You may start to like kind of notice patterns and start to get more comfortable. Some of them you might know in your head, and if not, that's okay. Just know that you can always go back and make a list if you need to. It's always a tool for you to use. So example 1, it says finding the greatest common monomial factor. So when we're dealing with polynomials, specifically like the ones that may have variables or like different exponents and stuff, your greatest common factor might be a little bit more complex than like 8. It might include variables, it might include exponents, and that's okay. So if I look at 1a, it says factor out the GCF from 4x to the 4th power plus 24x to the 3rd power. So the first part of it is pretty similar to just finding the greatest common factor between the two numbers. We first just want to find what is the greatest number that I can pull out. So what is the greatest common factor between 4 and 24? So you can make a list of the factors if you wanted to. We already have the list from 24, so that's nice. So, but the factors of 4, that would just be 1 and 4, and then 2 and 2. And if I were to order those, it would just be 1, 2, and 4. So if I look at the greatest common ones between 4 and 24, that'd be 4 and then 4. So that means that I can factor out a 4 from this expression, but I'm not done there because I still have to factor out like my greatest power, the highest power of x that I possibly can. And this is a little bit tricky because if we think about what each of like x to the fourth power and x to the third power is, so x to the fourth, that means x times x times x times x. So like 4x's multiplied together. And x cubed, that means x times x times x. So factors are just like different things that multiply together to get this final product. So we can see that x to the third power is 3x's. X to the fourth power is 3x's, but then it has one more x. So that means that x to the third power, that lower exponent, is automatically a factor of that x to the fourth power. It's a part of what creates that x to the fourth power. So that means that I can also factor out an x to the third power because that's a part of my greatest common factor between these two terms. So basically when you're looking at the like variable part of the greatest common factor, you can pull out the lowest power of all the terms. So like we had an x to the fourth and an x to the third. I can pull out an x to the third power because that's the lowest one, and x to the third will automatically be a factor of anything higher, any higher power of x. So when I pull that out, when I'm factoring something, I'm basically doing the opposite of distributing. So factoring something out is doing the opposite of distributing. If we think about what distributing it is, that's where you take the number in front and then you multiply it into the parentheses. But I'm going to take that number in front and I'm going to divide it out of what I originally had. Or we can think of using the like distributive property to kind of think, what do I need to put in there to get back to my original answer? So whatever I put first, that means that it would have to be 4x cubed times something that gets me back to this 4x to the fourth power. So like 4x cubed times what is going to get me to 4x to the fourth? Well, 4 times 4, or 4 times 1, that's the same, so that doesn't change. And then to get from x cubed to x to the fourth, I need to multiply in one more x. So that first term becomes an x. And then for the second blank, I need to think 4x cubed times what is going to get me to 24x cubed. Well, to get from 4 to 24, I have to multiply in a 6. And then to get from x cubed to x cubed, my power of x doesn't change, so that means I don't need to multiply in another x. And then once I'm done with those two terms, I can close my parentheses, and then that's my final answer. And just like when there's like, usually most problems have a pretty easy way to check your work. The easy way to check to see that you factored correctly, or at least you factored GCF, is to go ahead and just distribute it back in and see if you get back to your original problem. So if I were to just check this really quickly, if I distribute the 4x cubed in, 4x cubed times x becomes 4x to the fourth, and then 4x cubed times 6, that's 24x cubed. And that was our original problem. So that means that we factored out the greatest common factor correctly. And then for B, so factor the GCF out of 12x cubed minus 3x squared. So the first thing we have to do is to figure out the number part of the GCF. So in order to do that, we're looking at the 12 and the 3, or the 12 and the negative 3. So if I think, what is the greatest common factor between 12 and 3? Well, if one of the numbers is divisible by the other number, like 12 is divisible by 3, that 3 must be the greatest common factor because the only possible factors that come from the 3 are 1 and 3. So 3 would be the greatest. So that means that I can factor out a 3. And then next I have to figure out what power of x that I can pull out. So they both have at least x to some power. When I factor out the x to the whatever power we can, I have to take I have to take the lowest one out of all the terms. So one has an x cubed and one has an x squared. So that means that I can only pull out an x squared. And then when I'm pulling that out in front, like I said, I'm doing the opposite of distributing it. So instead of multiplying that number in, I'm dividing it out. So I can either use the distributive property kind of backwards to figure out what I need to keep in the parentheses, or you can think of it in terms of dividing if that makes sense to you too. So there's two different ways that I can figure out what goes inside my parentheses. The first one, using the distributive property backwards, like if I were to think 3x squared times what is going to get me to this 12x to the third power. That was my first term. So I have to do 3 times 4 to get me to 12. And then what gets me from x squared to x cubed, I have to multiply in one more x. And then for the second blank, I have to think 3x squared times what? Oops, I didn't mean to put the plus there, but 3x squared times what is going to make it back into this negative 3x squared. Well, it's basically the same, but I'm going from 3x squared to a negative 3x squared, so I have to put a negative 1 there, or minus 1, because 3x squared times negative 1 is going to get me back to negative 3x squared. So the other way that you can kind of approach it, if you are comfortable with like dividing, and when we were, not all that, sorry, and we were working on like properties of exponents and stuff, is to think, let me rewrite this a little bit. You don't have to write this second thing down because we're just going to, we're going to get the same exact answer. I just want to talk about a different way that you could approach it. So we figured out our GCF is 3x squared. And then think of it, I'm dividing that 3x squared out. So from the first term, which was the 12x cubed, if I do 12x cubed divided by what I pulled out, the 3x squared, well, 12 divided by 3 is 4. And then x cubed divided by x squared, that just leaves me with an x to the first power. And then for the second term, the negative 3x squared divided by 3x squared, well, anything divided by itself is 1. But since I'm dividing a negative by a positive, negative 3x squared divided by 3x squared becomes negative 1. So you can see we got to the same exact thing. So it's up to you on which process makes the most sense for you. You'll get to the right answer either way, as long as you understand exactly what process you prefer. And then just remember that you can check your answers pretty quickly just by distributing back in. Let me erase some of this because it got very cluttered. If I wanted to check my answer, I would just distribute that 3x squared back in. So 3x squared times 4x, 3 times 4 would be 12. X squared times x would be x to the third power. And then 3x squared times negative 1, that would just stay the same, but it would turn negative. So minus 3x squared. And that was what we had originally, 12x cubed minus 3x squared. Okay, so the next two are for you guys to practice on your own. I'm going to give you guys a few minutes. If you're a little bit iffy on it, just do your best, and then you can make the corrections later on once we go through it together. I'll probably give you guys about 2 minutes or so to work through those two. If you feel comfortable and you want to go down to like the extra practice ones at the very bottom, you're welcome to. Okay, so for A, factor out the GCF from 8y squared minus 24y. So the first thing we have to do is figure out the GCF between just the number part, the 8 and the negative 24. So between 8 and negative 24, one kind of trick you can use if you are still like feeling the need or the like desire to use or to make a list to find the GCF, I would just start with making a list for the smaller number. So if I were to make a list of all of the factors of 8, I know it would be 1 and then 8 and then 2 and 4. So if I were to reorder those from highest to lowest, that would be 1, 2, 4, and 8. And then from there, the highest one, the highest factor out of the factors of 8 is obviously 8. So you could think, is 8 a factor of 24? And if it is, then that's the greatest common factor. And if you're not sure if it is or not, you can use the calculator. You can do 8 divided by 24. And if it's a factor, you'll get a whole number out. So if you do 8 divided by 4, that's 3. And that means that 8 is a factor of 24. If 8 wasn't, then you would just go down to the next highest factor, which would be 4. But 8 is, so we can stop there and say that 8 is the greatest common factor between 8 and 24. So that means that I can factor out an 8. And then the next thing I need to worry about is what variable can I pull out, and more specifically, what power of that variable. So I have a y squared and a y. So any lower power, like y to the first power, will automatically be a factor of the higher power of y. So that means that I have to pull out just the lowest power that I see. So I have a y squared and a y to the first power. That means I can only pull out a y to the first power. So I can factor out an 8y. When I factor it out, I'm just doing the opposite of distributing. So if I want to figure out what goes in the parentheses, I can think 8y times what is going to get me back to 8y squared. Well, I would have to multiply in one more y, because 8y times y would bring me back to 8y squared. And then 8y times what is going to get me back to negative 24y. Well, I would have to do 8 times negative 3. That would be negative 24. And then since the power of y doesn't change, I don't have to multiply in another y, because I go from 8y to the first power to get back to negative 24y to the first power, so I'm not multiplying in another y. So y minus 3 goes inside my parentheses. If you prefer to think of it as kind of like dividing, you can think of, if I start with 8y squared and I divide out this 8y, I'm left with y. And then I have negative 24y, and I divide out the 8y, I'm left with negative 3. So whichever way kind of makes the most sense for you, just stick with that way. They both will always work. And then just remember that you can check it pretty quickly just by distributing back in. So if I distribute back in, 8y times y, that's 8y squared. And then 8y times negative 3, that's negative 24y. And that brings me back to what I originally had, and that means that we did it correctly. And then for B, factor out the GCF from negative 3x cubed plus 6x squared minus 12x. So now we have 3 terms that we have to worry about, but it works the same exact way. So first I'm going to check to see what number I can pull out. So I have a negative 3, a positive 6, and a negative 12. So kind of the tip is to start with your smallest number. Think about the factors of your smallest number. So our smallest number is 3. So the factors of 1 and 3, you don't have to write that part, but the factors of 1 and 3 are 3. So to check to see if they are factors of the following numbers or the bigger numbers, you just think that in our head. So is the greatest factor from 1 and 3 is 3. Is that a factor of 6? Yes, so I'll be able to pull it out of a 6 because 6 divided by 3 is 2. Is 3 also a factor of negative 12? Yeah, because negative 12 divided by 3 would be negative 4, so that works as well. So that means that my greatest common factor is 3. That's the number, the biggest number that can divide into all 3, 6, and 12 evenly. So not only that, but I'm also going to factor out a negative because that first number was negative. So I want you to try to get in the habit as soon as possible. If the first number in your expression is negative, I want you to also factor out a negative. It'll just kind of make your life a little bit easier later on. So because we had a -3, I'm going to factor out a negative along with my GCF of 3. And then from there, I need to figure out what is the highest power of x that I can pull out. So I have an x cubed, an x to the second power, and then an x to the first power. I can only pull out an x to the first power because that's the most that each one has. So I can pull out an x to the first power. Sorry, I feel like that was weird the way I said that. But I can pull out an x to the first power because I can only pull out the smallest one that's consistently across. So we had an x cubed, an x squared, and an x to the first power. So I can only pull out that x to the first power. If one of the terms didn't have an x, that means that I wouldn't be able to pull out an x at all. So if I factor out that -3x, remember I'm just doing the opposite of distributing. So I can think 3x times what is going to get me, or sorry, -3x times what is going to get me back to -3x cubed. Well, the -3 stays the same, but I have to get from my x to my x cubed. So to get from x to x cubed, I have to multiply in an x squared. And then for the next term, I have to figure out -3x times what is going to get me to positive 6x squared. So I would have to do -3 times a -2. And then to get from x to the x squared, I have to multiply in another x. And then now I have to think -3x times what is going to get me to -12x. Well, to get from -3 to -12, I have to multiply in a +4. And then to get from x to x, I don't have to change my power of x. I don't have to multiply in another x or anything like that. If you prefer to think of it as like the dividing option, you can think, let me erase some of this so I can write over it. You can think -3x cubed divided by -3x. What is that going to leave you with? Well, -3 divided by -3 would leave you with 1. You don't have to write it though. And then x cubed divided by x would leave you with x squared. And then 6x squared divided by this -3x. Well, 6 divided by -3 is -2. And then the x squared divided by the x leaves you with x. And then -12x divided by this -3x. Well, -12 divided by -3 is 4. And then x divided by x just cancels out to 1. So we end up with the same thing. Like I keep saying, it's kind of up to you on which way you prefer. Just remember that whenever you are done factoring something out, you can easily check your work just by distributing and seeing if you get back to your original problem. So -3x squared times x, or sorry, -3x times x squared, that becomes -3x cubed. And then -3x times -2x, well, -3 times -2 is +6. X times x is x squared. -3x times 4, -3 times 4 is -12. And then I'm not multiplying any x's together, so that x to the first power just stays the same. And that gets us back to our original problem. And then for the extra practice problems, for A, so we'll kind of, actually, I think I'm going to give you guys about a minute to see how much you work through or how much you're able to work through, and then we'll go through these together. I'm not going to do the full time, so if you don't like finish them, that's fine. I just want to give you kind of a head start to start thinking through it on your own. And then, like I said, in about a minute, we'll go through them all together. Yeah, what's up? Mm-hmm. Yeah, so that's okay. For right now, that's totally fine. It's just later on in the chapter, if you can get in the habit of if the first number is negative, pulling out a negative, it'll just help you later on. Yeah. Okay, so for 6x to the fifth plus 4x to the fourth plus 10x. So we first have to figure out like the biggest like number common factor that we can pull out. So kind of like a trick that you can use is start with the smallest coefficient that you have. So our smallest coefficient is 4. And then think about what the factors of that number are. So for 4, it would be like 1 times 4 and 2 times 2. So the total factors would be 1, 2, and 4. So 4 is the highest number. So if we want to think, is 4 a factor of 10 or 6? It's not a factor of neither. So 4 unfortunately can't be a common factor. So we need to go to the next highest factor of 4, which would be 2. And then you can think, is 2 a factor of 6? Yeah, so I can factor that out of the first term. Is it a factor of 10? Yeah, so I can factor out of the third term as well. So 2 would be my greatest numerical factor. So that means that I can factor out a 2. So I'm going to start by factoring out a 2. But then next I have to worry about what power of x that I can pull out. So I have an x to the fifth power, an x to the fourth power, and an x to the first power. So I can only pull out the lowest power of x. And that's because like x to the first power is automatically going to be a factor of x to the fourth and x to the fifth. Because x to the fourth is just like x times x times x times x. I don't know if I said that 3 or 4 times. And x to the fifth is x times x times x times x. I had to count that one. But that being said, like x to the fifth being x times x times x times x times x, that is not a factor of x to the first power because that's just 1x. So I can't factor out the whole thing. I can only factor out the x to the first power. So I'm going to factor out an x to the first power along with my 2. And then now I'm ready to figure out what stays inside the parentheses. So when I factor it out, I can think 2x times what is going to get me to 6x to the fifth. Well, 2 times 3 will get me to 6. And then x times what is going to get me to x to the fifth. Well, I'm starting with x to the first power. So I have to multiply in an x to the fourth power to get up to x to the fifth. Because remember when we like multiply powers, we add those exponents. So this would be like x to the 1 plus 4 to get me back to x to the fifth. And then I have to think 2x times what is going to get me to 4x to the fourth. Well, 2 times 2 will be 4. And then x times what gets me to x to the fourth. I have to multiply in an x to the third power. Because I would, again, add that 1 plus 3 to get to x to the fourth. And then x times what is going to get me to 10x, or sorry, 2x times what is going to get me to 10x? Well, 2 times 5 is 10. And then I'm just going from x to 10x, so I don't need to multiply in another x because the power doesn't change. So 2x times 3x to the fourth plus 2x cubed plus 5. And then remember, you can quickly check it just to make sure you did it correctly by distributing. So 2x times 3x to the fourth, that would be 6x to the fifth. So that's good. 2x times 2x cubed would be 4x to the fourth. So that's good too. And then 2x times 5 would be 10x. So that brings us back to our original problem. So that means that we pulled out the greatest common factor correctly. One other thing I want to kind of show you before we move on to B and C, whatever amount of terms that you start with in your original problem, that's how much will still be in the parentheses in the end. So like right here on A, I had 1, 2, 3 terms, and I had 1, 2, 3 terms in the parentheses. So it's not going to change the amount of terms that we have. Same thing up here. I had 1, 2, 3, and then 1, 2, 3 left over in the parentheses. And then up above, I started with 2 and I finished with 2 inside the parentheses as well. All that's happening is we're like dividing part of each term out, but we're still left with the same amount. So for B, these ones are kind of tricky with the multiple variables, I'm not gonna lie. So for B, it's 2x to the fourth minus 8x squared y squared. So same thing to start, we have to figure out like what's the biggest number that we can factor out. So we're looking between 2 and negative 8. So I know that 2 is a factor of 8. So that's automatically going to be my greatest numerical factor that I can pull out. So I can start with a 2. And then for my variables, remember that I just have to pull out like the lowest power that I see. Sorry, I was just reading the chat. George, if it's possible, can you wait because we're almost done with the notes? Okay, so the greatest like number that I can pull out is 2. And then for my variables, I can only pull out the like lowest power that each one has. So this is a x to the fourth, or sorry, an x to the first power and a y to the fourth power. And then the second one has an x squared and a y squared. So if I'm looking at what x's I can pull out, this is x to the first power and x squared. So I can only pull out the lowest of those two. So I can pull out an x to the first power. And then for my y's, I have a y to the fourth power and a y squared. I can only pull out the lowest of those two. So I can pull out a y squared. And that's because y squared is automatically a factor of y to the fourth, but it doesn't work the other way around. So I can pull out a 2xy squared. And then when I pull it out, I'm kind of doing the opposite of distributing. So I can think 2xy squared times what is going to get me back to this first term, 2xy to the fourth. Well, 2 times 2, or 2 times 1, that stays the same. So this would just be a 1, but we don't need to write that. And then I'm going from x to the first power to still x to the first power, so I don't have to multiply in another x. It looks like all I'm going to have to change is the power of y. So I'm going from y squared to y to the fourth. That means I would have to multiply in another y squared. Because remember, when we multiply powers, we add those exponents, and 2 times 2 would get me back to 4. And then next I can figure out 2xy squared times what is going to get me back to the second term. So 2 times what is going to get me to negative 8. 2 times negative 4 is going to get me to negative 8. And then what is going to get me from x to x squared? Well, I would have to multiply in another x. And then from y squared to y squared, there's no change. So I don't have to multiply in another power of y. So inside the parentheses, y squared minus 4x. And then if we want to check it, if I distribute that first term in to check, 2xy squared times y squared, that would be 2. X doesn't change because I'm not multiplying it by another x. And then the y squared times y squared becomes y to the fourth power. And then by the second term, 2 times negative 4 would be negative 8. The x times x becomes x squared. And then I'm not multiplying by another y, so the y squared stays the same. And that was back to our original problem, so we know we're good. And then for the last one, so 3a squared minus 9ab cubed plus 12b. So remember, first thing we're checking is what's the greatest number that I can factor out. Start with your lowest coefficient, which is 3, and then think, is that a factor of the other coefficients? So is 3 a factor of 9? It is, because it'd be 3 times 3. Is 3 a factor of 12? It is, because it'd be 3 times 4. So that means that I can factor out a 3. But then next I have to worry about my variables. So if we want to figure out what power of a I can pull out, the first term has an a squared, the second term is an a to the first power, the third term doesn't have an a. So because the third term does not have an a, we can't factor out of every term because it's not a factor of 12b. There's no a there. So I can't pull out an a. For b, it looks like the second term has a b cubed and the third term has a b to the first power. But because the first term does not have a b factor there, I can't pull it out. It's not a common factor of all 3 terms, so I can't pull out a b. So that means that my only common factor is that 3, and then I can go ahead and start to figure out what stays inside the parentheses. So 3 times what is going to get me to 3a squared? Well, I'd have to multiply 3 by a squared to get to a squared, or 3a squared. And then 3 times what is going to get me to negative 9ab cubed? Well, I'd have to do 3 times negative 3 to get negative 9. And then I would also have to multiply in an a, b to the third power, because with this 3, I'm not starting with any variables. So whatever variables I'm trying to get back to, I'm going to have to multiply those in. So 3 times negative 3 is going to get me to negative 9. And then I also have to multiply in the a, b cubed. And then 3 times what is going to get me to 12b? I have to do 3 times 4 to get to 12. And then I also have to multiply in a b because I'm not starting with any variables. So 3 times 4b would get me back to 12b. And then from there, we can just distribute to check. So 3 times a squared is 3a squared. 3 times negative 3ab cubed. That would be 3 times negative 3, so negative 9. And then the ab cubed stays the same because I'm not multiplying in another variable right here. And then 3 times 4b, 3 times 4 would be 12. And then the b would stay the same. And that gets us back to our original problem, so we know that we did it correctly.